I really kept it simple the last time. This time I've branched out a little bit. So we're going to express log 96 in terms of 2 and 3. So what you want to do first is write 96 in terms of 2's and 3's, just the number 96. If it doesn't come to you, most of the time it probably will not, and that's fine. You can do the factor tree. So what's 96? It's okay, 12 and 8. Okay, let's do 12 and 8. And what's 8? What's 12? It's 4 and 3, which is 2 and 2. And this is, we're not doing roots. Hang on, we're not doing roots. So this is 4 and 2, and this is 2 and 2. So let's take all of the leaves, right? Where are the leaves? I have 1, 2, 3, 4, 5, 6, right? So now, what's 96 made of then? How many 2's? 1, 2, 3, 4, 5 2's. So I can say that this is log 2 to the 5 times what? 3. And then there is a 3. Okay? Now I split this up and I say this is log 2 to the 5 plus log 3. Right? I'm using the product property. This is what you did on the homework. Now you bring the 5 down. So it's 5 log 2 plus log 3. That's the answer. So no calculator involved, right? You don't put it into decimals and so on and so forth. The other one, 32 and 9. We want to do the 32 separately and we want to do the 9 separately. So let's see what 32 is made of. It's 8 and 4. So this is, so you can either do, if you can recognize that it's 2 to the 5 from the beginning, all the more power to you. So this is 4 and 2, so it's 2 and 2, and this is 2 and 2. So basically I have 1, 2, 3, 4, 5 of these. So this is log 2 to the 5 over what's 9? 3 squared. That's what you meant. So log 2 to the 5 minus or plus? Minus log 3 squared, then what happens? There it is. Come on, you have to admit, deep down, you guys love these. You guys do. I won't tell anybody. I won't ruin your reputation, I promise. Huh? Do I love these? Oh my God. Yeah. Like, you have no idea how much I love these. Okay, so here we go. Okay, so expressed in terms of ln. So I messed up here. This should be an ln of 75. Okay, so we're going to express it in terms of 5 and 3. So can we break 75 down into 5's and 3's? Yeah. What is it made of? It's 75 is what? 25, 25, 25, right? So it's 3 times 25. I'm trying to do it mentally. And what's 25? 5 squared. So ln of 75 is really ln of 3 times 5 squared, right? So that's ln of 3, then what? Plus. Yep, and then what? Then you bring the 2 in front of the ln. Is that right? Okay, so you guys go ahead and do the next one. Oh, I forgot. You have an answer for me? Okay, what do you have?
I have ln 5 plus 2 ln
3. I was pointing to. So, okay, so how did we break this down? This was ln of 5 times how much? 9, which is 3 squared. So then that will be ln of 5 plus ln of 3 squared. So then that would be ln of 5 plus 2 ln of 3. If you're able to skip some of those steps, totally fine. but show me at least one intermediate step so I know it's your own original work. Okay? Okay. Okay, now we're going to expand. So when you expand, remember, you have to have as many logs as there are elements in the problem. So how many elements are here? 1, 2, 3. So that's how many logs you're going to have. All right. So log base 2 of what? 4. Now plus or minus? Plus log base 2 of m squared plus n to the 5th. Then what?
And then you bring the 5 and the 2 down.
You bring the 5 down. You bring the 2 down. But what about this here? Log base 2 of 4. What about that? Is there any way to write the 4 in terms of a 2 since it has a base of 2? It's 2 squared, right? So I write that as 2 squared. And it what? It's going to cancel now. So plus 2 log 2 of m plus 5 log 2 of n. So what about this log 2 squared? How much does it turn into though?
It just becomes n.
So this goes away, so you just have 2 plus 2 log 2m plus 5 log 2z n. I was looking at the one down below. Okay? Did we get how that turned into a 2? Okay. All right, let's do this one. So it's log what?
Log 2 plus log x plus log y squared minus log
Oh, look at her go.
plus log squared z.
Minus or plus? Minus log root z. Okay, so that changes to z to the 1/2, right? Okay, so then what happens to the half? Comes down. The 2 here comes down. So finally, what do I have? Log 2. Mm-hmm.
Plus 2 log y
Mm-hmm.
minus log 5 minus 1/2 log z.
All right. That's awesome, right? That's fun, isn't it? The more complex, the more fun these are. Otherwise, they're just utterly boring. Okay. Huh? So here we were condensing. I'm sorry, we were expanding. Now we're going to go backwards. Literally, it's like you press rewind and you just see everything going backwards, right? You know those videos that like just rewind? That's exactly what we're going to do. So when we're expanding, we had to have as many logs as there were elements. When you're condensing, and if you have to go all the way back to the original, how many logarithms are you going to end with? 1. So to condense a logarithm basically means to rewrite so that you end with 1 logarithm. Now, if initially each of the exponents were becoming coefficients, and now if I want to go backwards, what is each coefficient going to turn into? An exponent. So each coefficient will turn into an exponent. Each element which is added will be, okay, so each element which is added, so here, what is it? Numerator. So look, each one that has a plus sign came from a numerator. So now each element that's being added will be placed into the numerator, right? And each element which is subtracted would go in the denominator, right? So everything that you're adding goes in the numerator, and everything that you're subtracting goes in the denominator. Okay? All right. So let's condense this. The coefficients will turn into what? Exponents. So here, first off, I have log base 4 of x to the power of 1/2 minus log base 4 of y to the power of 3, right? Now, what is x to the half? Do I leave it as x to the half? That's root x. So I have log base 4 of root x. And what about the y cubed? Where does that go? It goes, does it go in the numerator or the denominator? Denominator. Right? So since it's minus log of y cubed, the y cubed goes in the denominator, and look at that, we condensed it. Okay? All right?
So basically, you're giving us the conclusion because if you go back to the answer.
That's exactly what it is. You're literally rewinding. Okay, so the 5 here is going to become an exponent. The 6 is going to become an exponent. So it's ln of a to the 5 plus ln of b to the 6. Now, you always start when you're condensing with the first term. So ln of a to the 5. Now, the other one, b to the 6, is it going to be a numerator or a denominator? It's numerator because it's being added. So you do times b to the 6. Okay? That's all. No. Yeah, if you have another ln in there, it's completely wrong. So if you did ln of a to the 5 times ln of b to the 6, completely wrong. I'll leave that up to you. If you really want to be a mathematician about it, parentheses will work, but I'll leave it up to you. Okay. So here, what happens to the 5? The 2.
It goes on by the 5.
Uh-huh.
And
And?
the 3, that's going to be.
Uh-huh. Okay, so go ahead and condense that.
ln parentheses 5.
Uh-huh. 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 Awesome. Awesome. Okay? All right. So, you guys want to do the next one on your own?
No,
I think you do want to do it on your own. All right, I'll give you. So this is log base 3 of what was it? Over
3 root y.
cube root of y. Awesome. Which 3? Which 3? This 3? Okay, so that it becomes y to the 1 over 3. Okay, so now here I have 2 log base 3 of x plus 1. So when the 2 becomes an exponent, it's of the x plus 1 entirely. So it's just this one I'll do because it's we haven't seen one like this before. So it's log base 3 x plus 1 to the power of 2 over just x. And that's it. You don't have to simplify. You don't have to do anything. This is how you leave it. Okay, I'll give you 20 seconds to do the next one. Go.
I got ln and then in parentheses x minus 4 to the 6.
Yeah, to the 6th
And then x cubed.
times x cubed, right?
Yeah.
Okay? And if you want to be meticulous about it, we can put parentheses around it. Okay? All right, questions on this? Okay. So, all right, change of base formula. We can change the base to anything we want to make it. All right? It's called change of base formula. The way it works is, so suppose you have log b of x, right? You can change the base. Now, suppose you want to change the b to an a. You want to change it from a base of b to a base of a. For some reason, that's just better suited for you. So what you do is log the base you want of x, that number, and then log the base you want of that original base b. What does it all mean? Let me do an example. So suppose you have log base b of 3, okay? And you want to change the base b to a base of 10, all right? So what we do is this. Log base 10 of this number 3 underneath log base 10 of this number b. That's the answer. Okay? So you changed the base from a b to a 10, from a 3 to a 10. So it used to be, okay, so let's do this one. Let's rewrite the logarithm as a fraction. So for this one, we're going to write it in terms of base 10, okay? Yeah, base 10. So, and I'll tell you why. So we're going to change to base 10. Okay, so it'll be log of 4. Remember, if the base is 10, we don't have to write it. Log of 4 divided by log of the lower number, 6. Okay? No, when the base is 10, you don't have to write it. It's like writing x to the 1. Okay, so we always change it to a base 10. The reason why is these calculators, like the scientific ones and the graphing ones, until about very, very recently, they always had a built-in base of 10. So we could never put anything into the calculator with a different base. So we would always have to change the base to a base of 10 and then put it in the calculator. So now I can put this in the calculator. It will be a decimal. So we can put it in the calculator and it'll be now you can, however, okay, so let me do this and I'll address that. Log base 4 divided by log of 6, not base, but log. Okay, and you have this one. So this is 0.7737. Okay. 4. The rule with logarithms, some committee somewhere of mathematicians decided that the rule with logarithms is we always go to 4 decimal places. No. Did I say 3? 4. If I said 3, it was a mistake. I know it's 4. Okay. So how would we write the next one? So it will be log of, right, over log of 4. Okay? So it's log of 4,212 over log of 4. Yeah. Okay. So there's that one. So logarithms, like logarithms are what? What does the logarithm tell you? You use a logarithm to find the what of something. The what? The exponent, right? You use the logarithm to find the exponent of something.